Good morning and welcome to Golden Horizons Academy YouTube channel. My dear students of class 12, as exams has already approached and knocked your doors once. So from today onwards you are going to prepare yourself how to score marks in physics, maths as well. So for physics, I'm going to make a small clips in every chapter from today onwards. You can go through it before your examination, and I'm also going to put small questions also which might come in your exam. लेकिन बच्चों, ये हर चीज करने से पहले मैं आपको एक और चीज बताना चाहता हूँ कि आपका जितना भी दोस्तों हैं उनको ज़रूर इस क्लिपों का शेयर कीजिए, उनका ओपिनियन लीजिए, उनको अगर कोई डाउट हो तो उनको भी बताइए कि डाउटों का क्लियर हम इसी चैनल से कर सकते हैं. तो योर इंस्पिरेशन ऑफ आस्किंग मी डाउट्स will make me complete inspire to fulfill your expectation in your examination 2025 for all the boards of class 12. Thank you. So today I'll be going with the chapter Huygen'S principle. In this 3 or 4 questions comes in 1 mark or 2 mark. I'll let you write those questions here. But before going to Huygen'S principle, we should not forget the great educationist. He is Christian Huygen, who is a great mathematician as well as a great physicist. But we should not forget he is the founder of wave theory. So today we are going to study about him and regarding wave theory. The very first thing, what is wave theory? How wave theory can be expressed, we can say in these words. तो वेव थ्योरी के जानने से पहले हमको ये जानना जरूरी है कि कोई भी सोर्स ऑफ लाइट हो, या वो पॉइंट सोर्स ऑफ लाइट हो या लीनियर सोर्स ऑफ लाइट हो, कोई भी सोर्स ऑफ लाइट जब होता है तो वो क्या करता है, वो डिस्टरबेंस तैयार करता है आजू बाजू में. यानी we can say that in wave theory a point source of light produces disturbance in its surrounding in phase, and that too within the same distance it disturbs the particles, making the particles to vibrate in phase with other particles as well. So chaliye, with the help of this I'll make you to write here the definition of wave front. So the very first thing, already I have said you that a 2-mark question appears in your examination, that is wave front. So what the question may be, number 1, what is wave front? So you can write here wave front, the locus of all the particles of the homogeneous medium. You can write here homogeneous medium, you may not write here homogeneous medium, which at any instant are vibrating in the same phase. As the disturbances are going in the same phase, the particles will vibrate in the same phase at a particular time, and all the particles will vibrate at a particular time where the distance of the particles is same from the point source of light. So we can say that the locus of all the particles of the homogeneous medium which at any instant are vibrating in the same phase is called wave front. So this definition is very important. Now wave front may be spherical wave front may be a plane wave front may be a cylindrical wave front. So we'll try to learn what is spherical, what is the cause of cylindrical, and what is the cause of plane wave front. So the cause of spherical wave front is due to a point source of light where the locus of the particles, if you draw the locus of the particles, it appears to be sphere. Another the kind of wave front is, number 1, as I said you, is spherical wave front. Number 2, cylindrical wavefront. Here the point source may be linear, so when we draw the locus, of the vibrating particles, it appears to be a cylindrical in shape. And number third is a plane wavefront. This plane wavefront is due to maybe a spherical, or due to maybe a point source of light, or due to be a linear source of light, but it should be very far away. It should be very far away, so that to get a plane wavefront. And with the help of this, we can explain what is a ray of light. My dear, the ray of light is always perpendicular to the wavefront. It is always perpendicular to the wavefront. I write the definition of this on the board. Try to check it out, the definition with their diagrams, as these questions often appears in your board examination, whatever the board may be. Okay, so this is a point source of light. So when it gets disturbed in the medium, the disturbance goes in the phase, and with the same distance at same interval of time, it acquires at same distance, isn't it? Now if we find the locus of the vibrating particle, the locus becomes in the shape of a sphere. So we say it as a spherical wavefront. So spherical wavefront can be defined as it is produced by the point source of light. This is the point source of light. The locus of all such points. So locus of all such points, which is equidistant from the point source of light. Equidistance from the point source is a sphere. One more thing we should not forget, that as the wavefront progresses, then there is a condition for the amplitude of a spherical wavefront, which varies inversely with the distance. We can write 1 by r as the distance from the source of light. So this is the most important definition. You must learn it properly. As already I have said you that the cylindrical wavefront is due to a source of light. Which kind of source of light? It's a linear source of light. Is due to the linear source of light. So we can say that the source of light is linear in shape. The locus of all such points. See, for each particle, the locus of all the points will lie on the surface. Of the cylinder. Another one is that as the wavefront progresses, the amplitude of cylindrical wavefront varies inversely as square root of the distance from this linear source of light. This is also one of the most important. We want to learn it from this. One more plane wavefront it is produced when the source of light, maybe it's a point source due to the point source of light, or maybe the linear source of light, producing spherical wavefront or producing cylindrical wavefront from a very far away distance, may be considered as infinity. Then we get this type of wavefront. You must know parallel beam wavefront is in this way. Conversing, which gets converses, is in this way. So these are the representation of the diagram. Diverging wavefront is in this way. So you must know the knowledge of this for your examination. Now let us coming to the point of Huygen's principle. So it's nothing but it is based on the geometrical construction of the locus of all the points. With the example of diagram, I'll take a source of light as a spherical source of light, certain portion of the source of light in which we'll have different points on that source of light, which can be considered as the primary source of light, and on the wavefront we'll be doing the points such that the points itself becomes a source of light for the secondary wavelet. I'll draw the diagram over here, just check it out. Now we will study about the Huygen's principle. Already in the beginning of this chapter, I said that the Huygen's principle is nothing but it is a simply geometrical representation of wavefront, means the wavefront which will be produced later in time. So let us consider to understand understand the Huygen's principle, let us consider a primary point source of light. So point source of light produces the spherical wavefront. Let us take a small portion AB as a primary spherical. So is the source of light, and let the different points A, B, C and so on be the points on this source of section. So finally this point A, B, C, these etc and etc, this also becomes the source for the secondary wavelets. So suppose this has been produced in time t, then after del t time how it will produce, will first try to understand. Let small c be the velocity of light. So the distance traveled will be the velocity of light into del t. So we can write c into del t is the distance of time. So with making the radius c del t, then what we can find out, let us make a very small wavelets like this. This is c del t. Again from this, let us make a small wavelet like this. Again from c, let us make a small wavelet. Now on enveloping this, suppose this is A, B, on enveloping this, we get in this way on the forward side, let it be termed as A dash, B dash, and on the backward also we get in the shape, we get the envelope in the shape of this, let us term as A double dash and B double dash. So in this pattern the wavefronts are produced. But what happens over here is Huygens has said that he has neglected the backward wavefront, and he has already assumed that there doesn't exist the backward wavefront, only the forward wavefront is produced. Forward secondary wavefront is produced. This is what Huygens principle explains in this way. But why did he conclude that this does not exist? Let me explain you with a theoretical way. As I said, I'll explain you with the example of giving the example with question. Why is the contribution of the wavelet lie on the back of secondary wavefront is zero? That I said you that this is the primary, this is the secondary forward one, and this is the secondary backward one. This is considered to be zero. Why? Because we know that the contribution of the wavelet that lie on the back secondary wavefront, making an angle theta with the normal is directly proportional to half into 1 plus cos theta. On the backward side, when we consider on the backward side of any wavefront, so this becomes theta angle is equals to 180 degree. So since angle becomes 180 degree, we know that cos of 180 is -1. So 1 minus 1 half into 1 plus cos 180, which implies half into 1 minus cos 180 is -1. So 1 minus 1 is 0. It implies 0. This is the reason why we say it is 0. So now we are going to discuss one more important question, that on the basis of wave theory using the principle of Huygens, that we have to show the laws of reflection as well as laws of refraction, which is very, very important for your board examination. You must know it. So now we'll try to prove laws of reflection using Huygens principle. So laws of reflection, that is we are going to prove that sin A is equal to sin R and all. So इसको हम प्रूफ कर सकते हैं दो तरीकों से, एक मैथमेटिकल से भी हम प्रूफ कर सकते हैं और एक प्रिंसिपल्स भी प्रूफ कर सकते हैं। तो सबसे पहले हम एक रिफ्लेक्टिंग सरफेस ले लेंगे, जिस रिफ्लेक्टिंग सरफेस को हम xy के नाम से लिखे हुए हैं। अब यहाँ पर एक P जो है, PA जो फ्रंट बनता है इसको, PA एक वेव फ्रंट है जो प्राइमरी वेव फ्रंट हम यहाँ पर ले रहे हैं। तो यहाँ पर जब PA वेव फ्रंट बनता है, सो लेट LA be perpendicular to this wave front and MP be perpendicular to this wave front. When it strikes over at here A, so when P strikes at P dash, then this portion it gets over till here. That means what? P dash is equals to A dash. Now since this is 90 degree and this is 90 degree, considering from this triangle and from this triangle, this angle is equals to this angle, this is equals to this, so making these two triangles as congruent, that means what? Finally we get this angle is equals to this angle. That means what? Sin I is equals to sin R, implies that I is equals to angle R. In this way we can prove that. In another way, let us find it out. Now since let us take Q at any point on this wave front. Okay, so then what happens when Q gets strike over K, and from K to it just strike over the secondary wave front, that means what? The reflective wave front of this, then the distance traveled from here to here and from here to here is equals to the, we can calculate the distance if C be the velocity of light, then the distance traveled QK can be written as velocity into time taken. Let T be the time taken, then velocity into time taken, that is C into T, or T can be written as, or C can be written, or T can be written as this. Similarly, KQ dash is equals to, we can write KQ dash, we can write C into the time T. That means what? We can write here time taken is equals to KQ dash by C. Then the total time taken T is equals to the total time taken from here to here and from here to here is given by this equation. Now considering the different triangles, we can say that already we know till here we have got it. Now T is equals to this. This is the equation 1, we have got it. Now my dear, you can see from this diagram that this is the wave front. Okay, whatever the points are taken on this, when it reaches over here and strikes to the secondary, the time taken will be the same. The time taken will be, if it is here, from here to here and here to here, the time taken will be same. Similarly, when P dash, the time taken from P to P dash is equals to the time taken from Q to K dash and from K dash to Q dash, what we have learned from wave front theory. So on considering this, now from this equation QK they have said here it is QK, so considering this triangle, this is 90 degree, so we can write QK as in terms of AK sin I, AK sin I. Similarly, KQ dash can be written as KB dash sin R. From here, what we can say, just replacing these two on this equation, we get T is equals to in this format, and finally we can see here KP dash can be written in terms of AP dash minus AK. Now on conclusion, what we get is, finally we get, on reassembling this, we get this. Already we have seen that on the point on any point on the wave front, primary wave front, to the point on the secondary wave front, the time taken is same. So the AK on the reflecting surface, the K point on the reflecting surface, different points on the reflecting surface doesn't matter with what the time is. So we can say that time is independent of AK. So considering this portion to be 0, we can get sin I is equals to sin I minus sin R equals to 0. Therefore, sin I is equals to sin R, or implying I is equals to R. This is number 1 point of reflection. Next, second question we can write it over here. Incident wave front, reflecting surface and the reflected wave front, they are all perpendicular to the plane of paper. Therefore, the incident ray, normal, reflected ray, they all lie in the same plane. With this, we can say that, with the hence proved, by wave theory, we can say, we can prove the laws of reflection. So already we have proved the laws of reflection, number 1 by mathematical way, number 2 in this way. But if in the question they give you to prove the laws of reflection with the help of Huygen's principle, so you have to go with the theory what I have proved in the latter phase of this exam. Thank you.